All right, so now we're at topic 3 of our first lesson. In a sense, this is kind of like part 2 of the last topic that we started. I'm not going to call it a part 2, but we're going to pick up directly where we left off, which was a graph of the equation y equals 2 times the quantity x minus 4 squared plus 3. So that's a mouthful. Let's take a look at what that actually looks like on a graph. Okay, so here we have it's not graphed yet, but we have our function, y equals, and then so on and so forth, a function of x. Remember that we said that this first number here is going to tell us how quickly the graph grows. This second number, the minus 4, is going to tell us that it moves right 4. And then this last number is going to tell us that it moves up 3. So here's how I graph that more specifically. We graphed it loosely in the last section. So I'm going to move from the origin. Instead of being at 0, 0, I'm going to move right 1, 2, 3, 4, and I'm going to move up 1, 2, 3. So this will be what we call the vertex of the parabola. That's the point at the bottom. And then instead of growing, a typical parabola goes out 1, 1, and then goes out 2 and 4. If you're trying to remember why, oops, 1, 2, yeah. If you're trying to remember why, go back and check out those initial notes that we took. So this is how a typical parabola grows. It would be like 1 squared is 1, 2 squared is 4. That's the idea. However, this is going to grow twice as quickly. So we have our starting point, and then instead of going out 1, up 1, it goes out 1 and up 2. And of course, it's a mirror image. And then instead of going out 2 and up 4, it goes out 2 and up 8, which would be like right here. And right there. Make that as smooth as I can. All right, and that's what our graph looks like. Now I'm going to turn this question, instead of it being a graphing question, which is what we've been talking about here, I want us to talk about it as if we were solving an equation. So if somebody said, solve this, when does 5 equal 2 times x minus 4 squared plus 3? So that's our new question. Everything on the right side here should look familiar. It's all those pieces of our parabolic graph that we just drew. And then on the left, instead of y, we've replaced that with 5. And so as we asked in the very first topic video, what this means is we're asking the question, when does my parabola have an output, a y value of 5? So instead of y, we're putting 5, and we're saying, when does this graph get a y value of 5? Or in other words, if I were to draw a line at 5, here's y, right? So y equals 5 is here. If I were to draw a nice line, where does the graph hit that value? And just like we saw in the original video, we get 2 answers because the graph equals 5 at this point here and this point here. So we're asking, what's the x value? Well, when x is 5 or when x is 3, we get an answer. So the answer is when x equals 5 or when x equals 3. So that's what it means to solve. It's when I find where the graph hits that particular value. In this case, it was 5 because of the number that we chose. And as usual, we get 2 answers. Now you might ask yourself, is it possible to get 1 answer? Is it possible to get more than 2 answers or no answers? What is the possibility here? Well, if I had asked, well, think kind of theoretically, if instead of asking when this graph equals 5, if I had said, when does this graph equal 3? That means when does it hit y equals 3 here? Yes, I would actually only have one answer, because at the base of the parabola, there's only one point that ever hits 3. And even more interestingly, maybe, use another color, what if I had taken this number and I had said, when does the graph equal 2? When does y equal 2 intersect with the graph? Well, the question is, does it ever intersect? And the answer there would be no. So actually, there are 3 different kinds of solutions. We can have 2 solutions. That's when there are 2 ways to get the number that we're looking for. We can get 1 solution. That's when there's only one way to get the number that we're looking for. Or we could get no solutions. In other words, there's no place where the parabola ever hits that value, because of the shape of the parabola, it limits what we would say the range of our value. It doesn't go from infinity to negative infinity. It doesn't cover all the values. So it is possible in this case to have no solutions that are possible. All right. Now, if that seemed a little bit chaotic, a little bit confusing, if that's not really looking at graphs, if that's not your cup of tea, you can relax, because the fact of the matter is, solving equations in this method is messy. It takes a lot of space, it takes a lot of time, there's kind of too much margin for error, and so that's where our algebraic methods come in handy. And here's what I mean by that. Let's start with a fresh screen. And we still have our original equation. Let's say that I took this and I went back to the solve for 5 equals. So this would be my question. Solve this. In the first part of the video, we answered that question with a graph. Now I'm going to answer it using our typical methods for solving an equation, which is isolate the variable. Get the variable by itself. And just like we did in our with our linear equations, we always want to start with the number that's kind of furthest out from x and try to remove it. We want to get x by itself, so we want to remove everything layer by layer until we have just x on one side. So the first thing I'm going to get rid of is the plus 3, because it's kind of the furthest away from x. And I'm going to do the same thing to the left and to the right. If you like to put a line through the middle to keep your sides organized, you can do that. So I get 2 on the left side equals 2 times x minus 4 squared, all that stuff, and then those cancel. So one layer is removed. Next, I have a 2 that's being multiplied. That's the next layer down. I can divide by 2, which gives me an answer of 1 equals, now these are going to cancel. So I get x minus 4 squared. Okay, now how do we solve for x? What's the next layer? Well, the next layer is actually this squared part, the parentheses squared. It's taking everything inside and it's multiplying it by itself. X minus 4 times x minus 4. How do we get rid of a square? The opposite of addition was subtraction. That's how we got rid of addition. The opposite of multiplication was division, so we got rid of the 2. Now lastly, what's the opposite of a square? How do we get rid of it? Well, if you recall potentially from last year or the year before, we can undo a square by using a square root. A square root does the opposite of a square. If you don't remember how square roots work, make a little note in your notebook right now to ask me tomorrow to expound on this. If you do remember, then this is going to be kind of quick for you, where we just say, okay, the square root and the square, they undo each other. So they're going to cancel each other out the same way that the addition and subtraction and the multiplication and division did. The square root of 1 is just 1. If you put it in your calculator, you'll get square root of 1 is 1. If you forget what the square root means, ask me about that in class and I'd be glad to expound on that. I'm not going to talk about it specifically right now. I'm making the assumption that you know the square roots. And then we have just x minus 4 left over. Why is it just x minus 4? Because that square root undid the square. So the key thing, the only thing that we've done right now that's new is to remember square roots undo squares, something squared. Now I don't really need these parentheses, I can just drop them. It's really just 1 equals x minus 4. So I can add 4 to both sides, and what I get is, writing it over here, 5 equals x. Which, if you remember, when we graphed our picture here and we said, when does this graph equal, let me see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. When does this graph equal 5? One of the answers that we got was when x is 5, y is 5. Now notice we didn't get a second answer. Like, where do we get that other answer? Where did that come from in our equation? All right, so I had to pause here and move their canvas so that we had a little bit more room. The question that we were asking is, what happened to that other answer? We found that we get the answer at x equals 5, but what about, if you remember, the other answer was supposed to be 3. Where did that 3 come from? And the answer comes right here when we took our square root. Something that we need to remember about square roots is that when we take the square root within an equation, what we're asking is, kind of like when we talked about absolute value, we're saying what number, if I squared it, would equal 1. So we're saying what number squared equals 1. And we said the answer is 1, and that is true, but it's not the only answer. Just like with absolute values, there's a plus or minus, because if I take 1 and square it, I get 1, but if I take negative 1 and square it, I also get 1. And let's watch what happens when I go back and solve my equation with negative 1. I add the 4, just like I did before, and I get 3 is the value of x. So when I solve and I use the positive, the square root of 1 equals positive 1, I get my first answer, x equals 5. When I go back and solve the equation with negative 1, the square root of 1 is negative 1, I get the answer x equals 3. So here's what we learn. In order to solve for a quadratic equation for x in a quadratic equation, there's a few things we need to remember. One is that we're still trying to isolate x just like we always have. If we isolate the variable, we'll find out what the answer is without having to graph. We don't have to go and graph a whole picture, try to figure out where the graph equals 5. We can just isolate x and get the same answer. So that's the first thing. The second thing we need to remember is that a square root will undo something that's being squared. So if I want to get rid of a plus 2, I subtract 2 from both sides. Do the same thing to both sides, but I have a plus 2, I subtract 2, it cancels. The same is true with roots and powers. So a square root and a square. I can, as long as I do the same thing to both sides of the equation, I can solve it just like anything else, but the key is square root will undo a square, and vice versa. Okay, lastly, the thing that we need to remember is when I'm solving equations, I need to give 2 solutions, a negative and a positive, in order to get the right answer. So write those down, where I'm going to do a last video that just shows us how to solve, just kind of from beginning to end. If I'm given an equation, solve this. It's just going to be a last example, but I'm going to apply these 3 ideas. Isolating x will give us a solution. Square root undoes a square, but whenever we use the square root, if we want to get the whole answer, we need to answer with a negative and a positive. All right, finish those notes, start the last topic, and then you will be done with this lesson.